Hello friends, I welcome you today to the first lecture on special provisions for pharmaceutical industry and plant layout. Today we are going to briefly discuss this topic. You yourself can predict if you are student related to pharmaceutical sciences and technology. So in this video we are going to see and discuss the following topics very briefly. So beginning with special provisions. Special provisions refers to the rules and conditions laid down for the purpose of drug manufacturing. These are to be followed and kept in mind while an architectural layout of the industry is to be prepared before the establishment of the manufacturing unit. So as the slide says that the premises should be suitable for the purpose of drug manufacturing. The building for the factory shall be constructed so as to permit the production under hygienic conditions. They shall conform to the conditions laid down in the Factories Act 1948, that is namely 63 of 1948. Any part of the building used for the manufacturer shall not be used for resting place. The walls of the rooms in which manufacturing operations are carried out shall have a height of 6 feet from the floor, be smooth and waterproof, be capable of maintaining cleanliness, and have no cracks or crevices. The flooring shall be smooth, even and washable to maintain cleanliness mainly, be in such a way as not to permit any retention or accumulation of dust, and have no cracks or crevices for the accumulation of contaminants. So proceeding to the next part of the slide, good manufacturing practices. GMP refers to the good manufacturing practices. These are the guidelines in accordance to the Code of Federal Regulation of Food and Drug Administration, that is USA National Archives. These guidelines guide us about the design and construction features of manufacturing plant, that is especially subpart C of part 211. It is clearly mentioned that design and construction features of buildings and facilities. Any building or building used in the manufacture, processing, packaging or holding of a drug product shall be of a suitable size, construction and location to facilitate cleaning, maintenance and proper operations. Any such building shall have adequate space for the orderly placement of equipment and materials to prevent mix-ups between different components, drug product containers, closures, labeling and in-process materials or drug products, and to prevent contamination. The flow of components, drug product containers, closures, labeling, in-process materials and drug products through the building or buildings shall be designed to prevent contamination. Again, to prevent contamination is the sole criteria. Operations shall be performed within specially defined areas of adequate size. Likewise, each and every area of an industry is specialized for particular operation like filling, sealing, production, uh, manufacturing, and area for packaging, or area for R&D, F&D, etc. So proceeding to the next part. So architectural layout. So what does we mean by architectural layout? Architectural layout refers to a design and planning for a building and can contain architectural drawings, specifications of design, calculation, time planning of building process and related documentation. So architectural layout are of three types, which are as follows: accommodation schedule, conceptual layout, and facility and equipment layout. So the designer must understand the product and process requirement and design the architectural layout accordingly. Accommodation schedule is the first step, as we can see it here, followed by conceptual layout of the pharmaceutical industry and the facility and equipment layout. So facility layout of the pharmaceutical industry must be an integrated design that satisfies the following conditions: Remember the conditions because these are very important. Process requirements, personal flow, organization and personal, which I mean to say, material flow, the products, components, raw materials, the equipment and layout requirements, operational access requirements, maintenance access requirements. So proceeding to the next part of the slide is the first type of architectural layout, that is accommodation schedule. So now if we ask what does accommodation schedule means, accommodation schedule, it defines all areas that can influence unit operations, every single unit operation actually required for manufacturing, as well as the relationships and the flows between them. Likewise, you can see in the diagram relationship, flows. It is a flow chart of a particular process of manufacturing. So the related process and the manufacturing process all are to be described with the help of accommodation schedule. Can be developed once the process is known. Obviously, with the help of designing the process appropriately, the accommodation schedule is to be designed by keeping in mind how the processing is being carried out. All the process flow diagrams should be complete. As I said that in accordance to the process, the flow diagrams are to be designed, also referred to as logic diagrams or bubble diagrams. So next part of the slide is conceptual layout, the second type of architectural layout of a pharmaceutical industry. Proceeding with conceptual layout, it is the design layout based upon the client version of the project along with the graphical details. As I said the word graphical details, you can see through the help of the diagram that each and every detail is very accurately described here, along with the dimensions, the structure, the position and or the location of the equipment throughout the pharmaceutical building. So what is a conceptual layout? Conceptual layout defines an early phase of the design process in which the broad outlines of function and form of something are articulated. It provides a basic idea of the client vision of the project. Therefore, the conceptual design involves an understanding and visualization of your needs. The conceptual layout drawing communicates graphically the details, the general look and the feel of the design without all the detailed engineering and development. It is the starting point of development. That means to say that before the construction has begun, the plan or the layout of the pharmaceutical industry is prepared as through the eyes of the client. That is the client vision of the project. As said before, the center of conversation in a design review that prepares engineering for the research tasks as hand. Derived from accommodation schedule, as accommodation schedule is the first type, and equipment sizing needs. Building blocks of equipment lines are developed. Blocks of rooms are assembled based on necessary adjacencies and process requirement. As I was saying, that each and every particular details are mentioned in the conceptual layout with the planned vision. So each and every small to big dimensional details like length, breadth, width, height of the room or the equipment to be used, everything can be or should be mentioned in this. So last of all, the third type and the final type, the facility and equipment layout. Just like a flow diagram, just if you focus, just like a flow diagram of a project life cycle, part of detailed design phase of the process followed, containing details about the room sizes, grids, structures and access route. Likewise, from where we are entering, from where we are about to leave the room, dimensions, structures, access routes, etc. So what is facility and equipment layout and what does it tell us about it? Scale drawing derived from conceptual layout. Scale drawing defines precise room sizes, dimension of rooms, structural grids, access routes. Building and fire codes means of egress are established in this phase. Building blocks of equipment lines are developed. Blocks of roofs are assembled based on necessary adjacencies and process requirements. As per the process requirements, that is how the process is being carried out, based on that the layout is planned. For example, as that you can see here the diagram of equipment layout of distillation tower, which is available in each pharmaceutical manufacturing plant, DM plant or demineralized plant or distillation plant. So it begins with pumps and ends with pumps, as you can see with the help of the flow diagram. So equipment and facility layout tells us about the details design phase of project life cycle, how the process is being carried out. So now we gather our focus on materials of construction and surface finishing. So now we would discuss how we should do the construction, what would be the recommended design, and what should be the materials used in the construction of a pharmaceutical manufacturing plant. So the following points are to be discussed beginning from here to here: flooring, surface finishes, ceiling systems, clean room doors, air showers, room pressurization. So flooring, while we do flooring, we should focus upon three main points, namely, as you can see here, aesthetics, durability, cleanability. These are the three main points we should focus when we are doing the flooring. Aesthetics, as we know, it defines that degree of how beautiful is it looking aesthetically, externally pleasing to eyes. And durability, we mean to say that the ability of the material to remain serviceable in the surrounding environment. And cleanability, we mean to say that ease of cleaning or cleanability of the surfaces of machines and equipment. So now, why are we using these three main materials, that is epoxy and vinyl or PVC sheet? Mainly for these reasons: they are hard, durable, long lasting surface with excellent chemical resistance. Now when we are working in a pharmaceutical industry or any chemical industry, when a chemical falls on the floor, or likewise there is any spilling, or there is any accident has occurred, so it can cause corrosion to the floor. We should keep that in mind and design the floor by keeping that in mind. So now epoxy is having advantages also, but it is very expensive to install. In that case, we should prefer in resin systems which are moderately priced. They are very popular in pharmaceutical industry and easier to install than terrazzo, but they are of moderate durability and chemical resistance. There is a tolerance level up to which it can tolerate. After that, it has to either it has to be replaced by a new one. And PVC sheet, that is, namely, you can search in net also, Mipolam. It is very durable, but in case it is highly populated area, it may not be so much durable. So coming to the next part of the slide is surface finishing. Process to alter the surface to achieve a certain property, that is aesthetics and cleanliness. This is the actual meaning of surface finishing. I will repeat what I said. Process, remember, it is a process to alter the surface to achieve a certain property, aesthetics and cleanliness. So why do we do surface finishing? The main motive is to prevent accumulation or collection of dust or microbial contaminants in cornered edges of flooring. Now in your home, you may have observed that we have edges of the room, corners of the room where dust get accumulated. But in case of industrial environment, if you have done industrial training, then the flooring, in case of the flooring, you may have observed that cope based tiles, here what I am saying, are usually used at the base of the tiles walls in lieu of the tile boards to create a seamless and watertight transition between the wall and floor. That is, here you can see accurately, and that's their primary purpose. They cover the joint at which the two surfaces meet in way that keeps moisture out. Now if there are no edges, so dust cannot be accumulated or water or moisture, so no microbial contamination may take place. Cornered edges are retrofitted in case if the industry when it was established there were cornered edges, they have to be retrofitted actually. Ceiling systems. Now what are ceiling? um, just let me explain what are ceilings actually. It is nothing but an overhead interior surface. You can see it is overhead interior surface that covers the upper limits of the room. Everyone in these days have actually ceiling in their homes actually. You be well acquainted with this topic. So what type of ceiling and what type of materials are recommended to be used in industrial or pharmaceutical industrials or pharmaceutical industrial environment? Mainly gypsum wallboard GWB with finished coat of epoxy paint. So what are the pros, that is advantages, and what are the disadvantages of this type of ceiling systems? It is flexible, it is easy to use, and since they are easily available, can be used, they are most commonly used in the industry. Now what are the disadvantages or the cons? It restricts future above ceiling access. Now in case this light has to be replaced or some kind of problem has been encountered in the HVAC system, now it will be much difficult to repair these spaces. That is the main disadvantages of this type of ceiling system. It requires careful coordination with other process during construction, that which I was saying earlier. Piping penetrations, in case there are overhead pipes carrying any type of flow of water or DM water or distilled water. HVAC diffusers, that is HVAC, heating, ventilation and air cooling. Light fixtures, which I said here. Filter housings. So for class 100 and for class 10,000 grade A and grade B areas, they are normally set. Radius scopes are often used in the ceiling to the wall junction as well. Ceiling to the wall junction, I refer to say this part, or this part you can say. Now as you see, in case of flooring there were cope bases. In case of overhead ceiling also nowadays they are doing cope bases are being attached, so that no accumulation of dust or spider webs get stuck there. So vision panels. So vision panels are the panels through which we look over to the other side of the wall. Here we can see the example with the help of front view. They are flushed with the wall to eliminate ledges, and they are maximum cases. Here you can see they are used, material is stainless steel frame, and obviously yes, it is very important, they are double pane glasses are used from both side. One two two layer glasses are used, in between vacuum is kept and free of gaps along the perimeter, as I was saying, gaps. Yes, most important topic, clean rooms. These are available in each of the industry nowadays as per ISO recommendation and ICH guidelines. This is a very important part actually to mention. So what are clean rooms? It is a controlled environment. As I was saying, it is a controlled environment where pollutants like dust, airborne microbes, aerosol particles are filtered pre-filtered, we should say, out in order to provide the cleanest area possible. Likewise, as you can see in this photo, when a personal is entering, first he is crossing the clean room. This room is actually clean room. Footwears are provided, sealed footwears. The particular uniform required is provided. Glasswares are provided which are to be collected. It is totally sealed chamber along with positive pressure from HVAC system. So these are facility ordinarily used as a part of specialized industrial production designed to maintain extremely low levels of particle. This is the main motive of clean room, such as dust, airborne organisms, vaporized particles. Now, clean rooms typically have a cleanliness level quantified by the number of particles per cubic meter at a predetermined molecular measure. This is very important to remember. Number of particles per cubic meter at a predetermined molecular measure. Now, for example, what I mean to say is that in previously you have seen that there was mentioned class 100 clean room. Now, what does it mean to say class 100? Class 100, it indicates that 100 particles per cubic foot of room. That's why I said you remember this definition. This is very important. So how do we determine the number of particles? This is the formula ISO has defined. The maximum concentration of particles per class and per particle size with the following formula. This is the formula. You can jot it down. Cn equals to 10 to the power n whole bracket 0.1 by d to the power whole 2.08. Now what is Cn? The maximum concentration of particles in a volume of 1 meter cube of airborne particles equal to or larger than the considered particle size, which is rounded to the nearest whole number. Now we take to the nearest whole number using no more than 3 significant figures. What is capital N? Capital N is the ISO class number which will be provided predefined. Capital D is the size of the particle, or you can say the diameter of the particle in micrometers, and 0.1 is the constant expressed in micrometer. Now the next part of the presentation is the doors. As you can see that full glass or half glass architectural aluminum doors are available with a variety of hardware options. Pivot hinges are provided here to pull or push surface mounted closures, concealed closures, panic hardware and lock sets. So this slide refers to the classification levels within a pharmaceutical manufacturing zone. It is classified into 5 zones, namely you can see when we are entering with the through the locker room or the entry room. Next to that will be the clean room before entering the pharmaceutical area or before crossing the corridor, or particularly you can say the aseptic corridor. Here you can especially see that class 1 million, class 10,000, class 100 C. When we are entering the main zone where the manufacturing is carried out, or after we are crossing the aseptic corridor, the particle number of particles in 1 meter cubic of air has been decreased from 10,000 to 100. So restriction of particles, you can see the difference here. What is the main that defines the main purpose of clean room. So now coming to the next part of the slide is room pressurization. This is also very important topic. Likewise, I will give you an example to make you remember. If you have gone or experienced an industrial tour, you might have noticed that opening of door of a manufacturing utility gives a sudden rush of air from the room, from the inside. This why does this happen? This happens because there is a pressure difference between the exterior here and the interior. There is a large pressure difference. So when we are opening the door, the pressure is released from the inside to the outside. Here the pressure is positive pressure and here is negative pressure. The pressure here is less. So sudden opening or pressure release will obviously will give you a sudden experience of air. A rush of air will be coming from inside because there is a positive pressure generated with the help of HVAC systems. In here you can see that highest pressure in class 100 room. Now interior zones are always having positive pressure. You should always remember it. Pressure are kept high for so that the particles which are suspended in the air, they should get suspended in the floor, so that the particles which are suspended in the air do not get mixed up or cross contamination do not occur when the formulation is being prepared. So now what does it says? USFDA, that is United States Food and Drug Authority, and European Union MHRA, ISO, requires that the rooms of higher grade must be at higher pressure levels. Higher grade means to say that class 100. The less the classroom number, the more the grade. Remember this. Typically 0.05 water column difference between classes. Now how are we determining this water column difference? I will be stating in this part. Ensures air flows from cleaner areas to dirtier areas. Now as I was saying, when we are entering from the exterior part of the corridor and in the interior filling room, there is a positive rush of air towards the outside. That's the reason. So class 100 filling rooms are always having the highest pressure because they are the filling room, and cross contamination, lots of microbial contamination or dust particles is thoroughly avoided. So how do you calculate water column? This is very important to remember. If you can understand, to calculate the hydrostatic pressure at the bottom of a container, consider H equals to 8 inches. Just consider for example of water. Sg equals to 1 p, psi pressure square per inch, 8 inches equals to, so the hydrostatic pressure P at the base is equivalent to 8 inches. You can remember it from here of water column. So 1 inch of water column equals to, now when they are converting in from each of water column to psi, this is the main, actually you have to remember this calculation. 1 inch of water column is 0.036. It is enough to remember till 3 significant figures. So this is the last slide actually which we are discussing now, cascading room pressure at different zone. So with the help of the diagram you may be able to understand that arrangement of pressure levels succeeding in different regions throughout the product life cycles across pharmaceutical manufacturing plant. Now the cascading means the flow of the pressure regions. Now you can see that this is class 1 million, this is class 10,000, where washing before filling vials are washed. This is the preparation preparation of formulation is taking place. This is the corridor, pressure is very much less. Now what I was saying earlier also, filling room has the maximum pressure and the classroom remains minimum because it is of the highest grade. So these are the references which I have used while preparing this presentation. The most useful book you can also come across, Pharmaceutical Production and Management by Dr. CVS Subramanian. And these are the notes. I have made a OneDrive folder. I will be uploading these notes, and you can find the link in the description box from where you can download this slide also. And obviously, while preparing the slide, I have to refer the Code of Federal Regulations. This is a must for quality assurance. So thank you everyone. So if you have experienced an awesome journey, and if you have understand something or less, some more, you are hoping to me in more detail, please do like the video and subscribe the channel. Thank you for viewing this video, and after watching this video, if you wish to get the notes based on this topic, I am again saying that I have provided the link in the description box from where you can download it and prepare accordingly for your necessary preparation in case of examinations and study. Do good and be good. Thank you. Please subscribe. I request, please subscribe and like the video.